Alright, so welcome back. This video is going to be about graphing cosecant functions. I'm going to start with graphing sine, but hopefully you know about what a sine function is going to look like, how it acts, how it behaves. So if you haven't, go back and watch my 4 videos on graphing a sine function. You can find them in a graphing trig functions playlist. But you really do want to know how to graph a sine function completely prior to graphing a cosecant function. But here we go. So I'm going to start by graphing y equals sine of x. So I'm going to put some points here, right? So I go by 2's just so that everything's spaced out and looks nice. And so here we go. So if you know, sine starts at 0, 0, the start of its first period. Then it goes up to pi halves 1, then to pi 0, and then to 3 pi halves negative 1, and then 2 pi is 0. And then we're going to keep the pattern going. Alright, so that looks good. And we can label our axes. That's negative 2 pi, negative 3 pi halves, alright, so I'm going to graph that. And that is what a normal sine function looks like. So let's try to think about, and that's 2 periods of sine function. Let's think about how sine and cosecant are related. So we know that sine of x, right, is related to cosecant because it is 1 over cosecant of x. Or you could think of it as cosecant of x is 1 over sine of x. And so they are reciprocals of one another. And so when you take a look at this, I want to focus my attention on this one, right? Cosecant is 1 over sine of x. So as we are going to sketch y equals cosecant of x, all right, as we sketch that, we're going to actually use the graph of sine to do this. So let's think about it. Cosecant is 1 over sine. So this part, the sine of x, that's the y values in our graph. So let's just start right at 0, 0. So if we go to 0, 0, and I'm going to do it in orange, right? If we go to 0, 0, and we take the y value and we do the reciprocal, what's the reciprocal of 0? The reciprocal of 0 is undefined. And now all of a sudden, we have ourselves an asymptote at 0. The reciprocal, now if I go to pi halves, 1 is the y value. I do the reciprocal, the y value is still 1. Now I go to pi 0, we just talked about it, the reciprocal of 0 is undefined, so now I get another asymptote. The reciprocal of negative 1 is negative 1, so here's another point there. And the reciprocal of 0, once again, obviously is an asymptote. It's undefined. So the first period of the cosecant function has 3 asymptotes. Take a look, and they're spaced out. Wherever the normal sine function hit 0, we ended up with a vertical asymptote, which means we would have a vertical asymptote here at negative pi, and we'd have a vertical asymptote here at negative 2 pi. Okay? So with that said, what happens with stuff in between, right, these points? So let's just pick a point right here. Let's say that this is pi 6, you know what I mean? So the sine of pi 6 is 1/2. So what's the reciprocal of 1/2? It's 2, so at pi 6 it would be there. Also at 5 pi 6, right, it's also 2. And so there's our graph. It kind of looks like this idea where it's just going to flip up. And so instead of our normal sine curve, we're going to get these things that look like asymptotes. And then with the negative ones, it too would flip down, right? And so the idea here that you have is cosecant is going to look like this graph that would be the reciprocal, right? And when doing the reciprocal of numbers less than 1, they become bigger than 1, which is why you get these parabola looking things. And I'm actually going to delete the sine graph. So there you go. That right there is y equals cosecant of x. And so let's take a look at this a little bit. Let's analyze it. So what do we notice? We notice the domain's not all real numbers. So in this case, the domain, right? The domain is going to be written as we describe, right? We're going to describe the asymptotes, so it'll be x equals, and we're going to pick an asymptote. I'm going to go with 0. And then notice how they're spaced out. They're spaced out not by 2 pi, which would be the period, but they're spaced out by half the period, which is just pi. So pi n, and if you look at the graph, notice that we have asymptotes spaced out by pi, and those would be the values that the graph can't equal, the function can't equal. And then our range, we're actually going to use the union, because notice the graph is going all the way down to negative infinity, and then it goes up to 1, or negative 1, excuse me, with a bracket, and then it kind of jumps over the values in between negative 1 and 1, and then goes up to positive infinity. Okay? And so as we look at the domain and range of a cosecant function, there's some really good things, and we can see how it's different, but we also can see how it's related to sine, right? Wherever that sine graph is hitting the middle line, you're going to have asymptotes. And then I don't make people find any more points. Normally I just say, you know, it's going to be parabolas. If it's above the middle line, the parabolas will open up, and if it's below the middle line, the parabolas will open down. So here we go. There's your graphing form, right? Your graphing form is the same as it has been for all of them. Just remember, we're working with sine, right? Something related to sine, and so things that we should remember, the period is 2 pi of sine, so the period of cosecant is also going to be sine, or excuse me, is also going to be 2 pi. So our period change, right, can be found by doing 2 pi divided by b. D is still our vertical shift, A still tells us the amplitude and reflections, and C, don't forget, you need to make sure that this is factor if necessary, so that you can see what the actual shift is. And remember, this sine period normally starts at 0, so our starting point will be wherever the graph has been shifted to the left or to the right, if it has been shifted left or right. Okay? But if you can graph a sine function, you can graph this. So kind of going to walk you through the process now that you have a picture of what it's going to look like. Kind of walk you through a problem with just basic transformations. So we got y equals 2 plus 3 cosecant of x. So the first thing I would do is I would encourage you to graph y equals 2 plus 3 sine of x, but don't connect the dots. Right? So you should, as I said, watching this video, if you don't know how to graph a sine function, then that's not good. Go back and watch the first 4. But if you can graph a sine function, I want you to graph y equals 2 plus 3 sine of x, and then just don't connect the dots. We'll talk about how we can create the cosecant function from that. So let's break it down. Our amplitude is 3, right? There's no period change, so our period is still 2 pi, which means we're going to just have a length of 2 pi. Also notice there's no phase shift. So since there's no phase shift and the period's 2 pi, we're going to start at 0, we're going to end at 2 pi, and we can multiply our period by 1/4, right? And that will tell us what our notches are going to go by. So they're going to go by halves. So there's pi halves, there's pi, there's 3 pi halves. So the basic kind of x-axis. Okay, and then last one, vertical shift is up 2. Alright, so we're going to label our axes. I'm just going to go by ones. And then I'm going to put in my midline. My midline is going to be up 2. Alright, so we're going to negative 2 pi, negative pi, negative 3 pi halves, and negative pi halves. And then the positive counterparts over here. And 2 pi. Alright, so like I said, we're going to graph y equals 2 plus 3 sine of x. So here we go. So sine starts at the middle line, but here's our middle line. And then we're going to go up 3, down 3, down 3, and then back up 3. And then follow the pattern for the second one. Alright, so check it out, right? You're not going to connect the dots since it's cosecant. And since it's cosecant, wherever the sine function normally is 0, right? Or in this case, where it would hit the middle line, because the sine function would be 0 there. So wherever that is, we're going to put an asymptote. Okay, so it's hitting the middle line there. Lots of asymptotes today in this graph. Okay. And then if the point is above the midline, right, if it's above the midline, then we'll have what looked like a parabola but opening up. And then if it's below, that parabola will open down. And that's pretty straightforward. Okay. And so the last thing we could do is domain and range. So the domain, right, is x can't equal. We're going to pick an asymptote. Since it's at 0, I'm going to pick that again. So 0, and then notice what they're going by, right? They are separated and going by pi. The asymptotes are, so pi n. That will change, right, when your period changes. If your period doesn't change, then the asymptotes will be spaced out by pi, half the period, which is 2 pi. And then our range, it's not all real numbers, so we're going to go negative infinity. The lowest value is negative 1, or where it goes up to is negative 1, bracket, union, bracket, and then it seems like the y value of 5 to positive infinity. Okay, and that would be your basic cosecant function. Hopefully that makes sense. If you want to hit pause, we're going to do another one. And so I put one problem, it's got all the transformations in it. So if you want to hit pause, feel free to go ahead. And then after you finish graphing, y equals negative 2 cosecant of 1/2 x minus 2 pi plus 2. Then you can check to see if you got it right, hit play again, and see how it goes for you. Okay, but here we go. So I'm going to graph the sine function of this. So my amplitude is 2, and I'm going to make sure I do a reflection. My period is going to be done by 2 pi divided by 1/2, so that's going to be 4 pi. I'm going to factor out the 1/2 on the inside. I'm going to get x minus 4 pi. So that means we've moved to the phase shift, right, our horizontal shift is right 4 pi. Okay. And then our vertical shift is up 2. Alright, so down here I'm going to do my x-axis just to kind of get a picture of this, see where I'm at. So I've shifted right 4 pi, so that's going to be my starting point because sine normally starts at 0. So I'm going to shift to right 4 pi, but then my period is 4 pi, and so this will go 8 pi that way and then 0 this way. So that makes things nice because then if I multiply 4 pi right here by 1/4, that would just be pi, and that'll tell me what my notches are going by. So basically everything's going by pi, which makes things really helpful. Okay, and so I'm just going to go over here to the graph and start labeling 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, and that's how far I got to go. So pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. Alright, cool. And then we're going to add in our midline. So our midline is going to be up 2. Okay. And then we're going to graph our sine function points, but then remember we're not going to connect the dots. So sine normally starts at the midline. So here we go, starting at the midline, but then I'm going to go down 2. So 1, 2, back up 2, down 2. Okay, and so there are our points. Remember, everywhere it hits the middle, that is going to be our asymptote. Okay. And then if the points are above, make a parabola opening up. Points are below, make it open below. And there's 2 periods of a cosecant function. Alright, let's real quick get the domain. So the domain is going to be x can't equal, and we're going to use 0 as our asymptote. That makes life easy. And then notice the asymptotes are separated by 2 pi, so x can't equal 2 pi n, where n is an integer. And then the range is going to be, right, from negative infinity up to 0, bracket, because it can use the value of 0, and then it skips over all that stuff in the middle and then goes up to 4 to infinity. Alright, and there's the graph. Thanks for joining me, and have a great day.